Hey there and welcome back to the Code Wrinkles channel for a brand new video. In this one we will talk once again about clean architecture, but from a totally different perspective. And we'll see exactly how we can still stick to the clean architecture principles when we are faced with a scenario where we have to work with entity framework database first. This is actually a very interesting topic, and no matter if clean architecture or not, I think that this topic is actually not covered at all. And in fact, I also got a lot of comments on different videos on software architecture, and not only like, okay, everything's nice and fine, but how should we actually do things, or how should we think through when we are faced with this scenario of entity framework core database first migrations? And there are some fair concerns to actually think about that. Why? Because that is a scenario that's kind of like a little bit special, I would say. And in this video, we will once again do a very practical approach to this, and we'll actually have a very backbone of an application. And we will try to actually simulate what we would have in a real project when we have to suddenly actually think about, okay, how do we get our data entities or entities for Entity Framework Core to work actually with our clean architecture principles when we actually don't do code first. Okay. So before we really start with this, I really want to say a few words on why actually this might be a problem. Now, the big problem is that, the scenario is actually fairly common when it comes to real projects, because a lot of times that you start to work for a new customer, they want to build a new app. But a lot of times they already have a lot of data, or they already have data structures in their database that serves maybe other applications, but the same data is actually the baseline or what we actually need for the new application that we have to develop. So in most cases, in such scenarios, the customer will never agree to actually create a totally dedicated database where we could do our code first stuff. So in this scenario, we will have to stick to the customer requirement and work with Entity Framework Core reverse engineering or database first migrations. And the problem with that is that when you actually try to do that, we will see just in a second, you actually get a lot of problem from the fact that Entity Framework Core kind of like scaffolds all the data and the entities and the DB context based on the existing database. So then the question arises, okay, but if Entity Framework does this, what about my domain layer? Because we usually create a domain layer and we use the exact same entities actually for Entity Framework Core. But before actually going deeper into this discussion, let's actually see in action what we have. So first of all, I have here a very basic application, like where we have a domain layer, where we have this concept of payment request. And take a note here, we have this processing date. We have this authorizer, which is a string in this case, and we have an amount, which is a decimal. So it's very basic, but you will see that that will actually serve the purpose that we want to cover in this video. And then we have an existing database here. Also, once again, the database structure is very simple because we just want to simulate a real scenario. And I'm really sorry for the light background, but I didn't really find a dark background for SQL Server Management Studio. However, you can here see that we already have this table, which is the payment request, that has a very strange naming. So don't take the namings that we see here in this database as a best practice, because they are certainly not. However, when you work on existing projects, databases might be very old, like 10 years, maybe also 15 years. And a lot of times this means that those that actually created the database followed some very popular patterns or best practices in those times, but those patterns or best practices not necessarily are today the best practices. So you'll see a lot of very strange or different naming conventions or ways of naming different things in an SQL database in older projects, and you have to work with that actually. So that's why I kind of like wanted to simulate also this aspect here in our video. However, if we take just a brief look at the structure that we have here for this payment request in the database, we see that we have here a processing payment date, and that we have here, for instance, also a payment due date. And remember, in our domain, we don't have this payment due date. We don't actually need that. And then we have this authorizer first name and authorizer last name. And in our domain model, we have only authorizer, which is a string. And then we have this payment amount, and that's actually it. Cool. So if you want to perform a database first approach in your application, what you will need to do is actually scaffold that DB context based on, or scaffold the entire data model based on the existing database. And to do that, we actually have a command that we have to run either in the package manager console if you are in Visual Studio. But what we'll do here is we will use the terminal. And first, because I want to make sure that we scaffold and we get all the data that regard the database, I want to get them here in this data access layer. And here I have already created two folders, like we have here data, and here we have data models, and we'll see just in a second what we actually want to do with that. So let me just first of all, let's take a look into directory structures, and let's change directory to dull. And let's also do adhere here, and I guess we should be good to go because we have these folders, data and data models. And by the way, guys, what I also have done as preparation, I have installed all the necessary entity framework packages, and you will see later also mediator, so we don't really have to install packages right now during the video, but of course you need to install all the necessary entity framework packages and all the packages that you might need to actually run this application. Cool. And now comes the fun part. So when we do a database first migration or a database first approach, we actually need to use this command, which is .NET EF, which is, well, how entity framework comments start in the .NET CLI. And then, well, we say that we want to scaffold the DB context. We provide here the connection string to the database, and we specify which driver we want to use. We have SQL Server, so we want to actually use this SQL Server driver. And then we have here two parameters, like a context dir, which is the context directory, and I want the context directory to be data. So the DB context, I want to have it in the data folder. And here we have a models dir or output dir, and this is where actually all the entities will be created, and I want all the entities to be created in the data models folder. So let's run this command right now, and theoretically it should take just a few seconds. The project should be actually built, and then everything from our existing database should be scaffolded in our application. Okay, the build succeeded. I guess I get here some warnings that the packages are not really on the same versions. And here, for instance, if I go here, you see that already I have here these folders that are populated. So if we go to data, we see that we already have this DB context. I guess I can close the terminal. So we have here the DB context, and here I would say, okay, it has two constructor, regular stuff that we would actually expect here on a DB context. The only thing is here, well, they also use this this on configuring override. And the most important part is this on model creating, because here is where actually entity framework core models all the data and the relationships and the properties based on what it sees actually in the database. So it's actually the reverse, like we do a code first migration. When we do a database first migration, the DB context gets created and all the entities are actually created, and the model builder snapshot is created based on that. Cool. So that is our DB context. We actually don't really have to touch this. And if we go here to the data models, we have here this payment request, and this payment request, okay, it has the payment ID. We see that it has two dates. It has this authorizer first name, it has this authorizer last name, and more important, it has this payment amount. So first of all, let's maybe make this non-nullable, because I really don't want this to be nullable. And also this date I don't want to be nullable. So that's a very, very minor change that we will do right now. And this is because in the database, it was not set to not null. So that's why this actually happened. Cool. So we are here, or we are facing right now this problem that I actually mentioned earlier. So if we take a compared look, like we have our domain model, which contains kind of like these 4 properties or 3 properties, because this is kind of like a default. And we have this payment request that contains more properties. So a lot of times I have seen people do the following thing. I have seen people just go here to the data model, copy actually all the properties or the entities or the entire entities actually, and move them to the core or to the domain layer. But this is conceptually and practically totally wrong. The reason why this is wrong conceptually, first of all, is that we used to think, and I don't really get exactly why, but we used to think that, hey, our domain model or the entities that we have in our domain model, like this payment request here, they are database entities. But if you have taken a look at my previous clean architecture video, you will actually find out that this is not true. Our domain entities, our domain model is the core of our application. It is what actually models the real world scenario that we actually want to solve or reproduce for a computer. It models it with the entire logic. And most of all, clean architecture is also about the rich domain model. So we need to have a lot of behavior there. And I would also like to maybe do some kind of a joke here, because you know that champagne is only champagne if it comes from a certain region of France. The same way we can see that clean architecture is only clean when it has a rich domain model. Otherwise, it's not really clean architecture. It follows some principles, but it's not really clean architecture. So rich domain model is the really important part. And if you think from this perspective, you will soon actually figure out or understand that the domain model that we build, they are actually not database entities. It's our domain model. It's the core of our application. Now, Entity Framework Core is smart enough that we can avoid writing a lot of boilerplate code, and we can simply reuse what we have in our domain model as also entities for Entity Framework Core. But once again, conceptually, they are two totally different things. Our domain model is our domain model and it remains the same. And what Entity Framework Core does well, that's a totally different story. But it's not, or please do not ever again think about the classes that you have in your domain or in your core project as being database entities, because they are not. They are our domain model, and it happens only that EF Core knows how to use that to actually also create a database for that. But it's not that they are database entities. Cool. And if we have this distinction, actually, we already understand that if we have this kind of scenario where we have the database first approach, where actually the entities that get scaffolded during the scaffolding process are actually fundamentally different than what we actually need in our domain layer, in that case, it's clear that you cannot that you really don't have an overlap. So in this case, you have to keep everything separated. Like the entities for the database, we have in our data access layer in the data models folder, the entities that actually build or create our domain or core project is in the domain. So the idea is that, of course, in this case, this brings in some challenges, because we have to find a way, of course, to actually transform the data models that we have here into our domain model. So here are the next steps into how we could actually do this and keeping everything clean. Now, the first thing that we would actually need to do here is, of course, creating some repositories. And by the way, when you have this case of or this scenario where we use a database first, in this case, or this is an example for a scenario where it is actually very important to actually use a repository. And I have a video, for instance, where I discuss, okay, when should we use repositories, when we shouldn't, or what are actually the pros and cons of using a repository. But this specific scenario is actually a very good point, or it really makes use of this concept of repository, and we will see in a second also just why. So let's go into the abstractions folder, and let's add here an interface I request repository. Okay, hopefully I have spelled it correctly. And in this I request repository, we will also have, for instance, this small method that we define here, import missing references, that actually is retrieve payment, and we want to retrieve a payment by the payment ID. So this is actually the repository. And then, of course, where do we actually implement the repository? Well, we implement the repository, of course, in our data access layer. So in the data access layer, we will actually go here and create a new directory, a new folder, and we'll call this repositories. And in this folder, we will add here a new class or interface, and we'll call this payment request repository. Okay, and that would be the payment request repository. Cool. Now what we would have here, and I will also copy some code because it's fairly straightforward the way that we actually create a repository. And by the way, if you're not familiar with that, what we have here is actually, let's add the missing references here, and here the payment request and the payment request here. Okay, because this one should be not in the data models, but it should be, let's remove this one and let's have this payment request here. And it still adds this one. So let me manually do this because we need the one from the domain. So using domain, how did we call this? Is this not domain? Okay, the using doesn't work here. Just a second. Okay, so I have solved this right now because I have added everything that we needed here, and we have here the domain models. Actually, the project reference was missing, but now everything is correct. Now, what I wanted to actually discuss here and show you why we actually need a repository in this case, because this is the 100% the definition of a repository. So the repository works with the data model. In our case, it works with the payment requests, which are those that are defined in the database with all the properties. But in the end, it should return a domain model. So it should return a payment request that is actually, if we hover the mouse here, part of our domain models. So this means that what we do here is actually we get this payment from the database, but then we manually actually do the mapping from the data model to our actual domain model. And then of course that we return this from the repository. And that's actually very, very important. Of course, you could use AutoMapper here. And if you go for AutoMapper, I would suggest you maybe installing AutoMapper without dependency injection directly here in this package and working here with Mapper. So I wouldn't actually use the DI version here to keep it as separate as possible, but you could totally do that and configure mapping profiles that would map for your data model to your domain model. So that's actually also a very valid option to do, but I wanted to do here this manually to actually understand that what we do or why we need a repository in this case is because this is the perfect spot or the perfect place where we can actually take the data model that we get from the database and transform it to our domain model with all the rich logic that might be or that might surround it. So that's actually very, very important. Now that we have the repository, there is of course the next thing that we have to think about. Okay, how would we actually proceed with the application layer? Now, of course, for the application layer, we will have to also create, or we will actually do this two ways, because usually you can do this through a more traditional, let's say, layered approach or services approach, where you create a service, or you can do this in CQRS style with mediator. So we will implement them both to actually have an overview about how we can actually still keep the architecture clean, even if we use services or if we use actually CQRS and mediator. Cool. So in order to actually do that, in our abstractions here, we will, in the domain, we'll create a new interface, and we'll call this interface iPayment request service. And in this iPayment request service, we'll also have a task payment request, and that actually will retrieve or return a payment. Now, the most important thing here, of course, in this service, we will not have a lot of logic, but I just want to actually have this look and feel about how we can proceed to that. So of course, the next thing is we need to actually implement the service. And for this, I have created a project which is called Application Classic. So this is the more classical approach to the application layer where we kind of like use services. And here that will not be very, very complicated. So what we will actually do here is we will just create a class which is called payment request service. So I won't create a folder here, just a class. Now payment request service, and that would actually be the implementation for this service, of course. And this one should implement payment request service. And of course here we'll also need to actually add a reference to our domain project, because otherwise it doesn't really know how to actually do that. And implementing this one with task, let's also make async, and it should actually work pretty fine. This being said, let's also go to the repository, because I don't remember. Yeah, we have also here to specify here that we want to have or to inherit or to implement the iPayment request repository. Here theoretically, okay, but I should have the repository. Where is it? I request repository. Okay, I have named it wrong. It's I request repository. And here theoretically it should be import the missing references, and it should be good to go. Cool. So we have also the interface and the implementation for the repository, and now we are actually doing here the implementation for the service. Now I will just simply also use a code that I have already created, because it's mostly boilerplate code that you would have in this. It's not the iPayment request repository, but it's I request repository. And sorry for this naming here, that was really, really bad. It should be iPayment request repository, but that's a little bit late to change right now. And we have here this retrieve payment, and what this actually does is only uses the repository, and it retrieves the payment from the database. And of course, the repository, once again, is the part, or well, the layer that actually translates a data model that was created by Entity Framework Core to our domain model. So here in the service, we can return this directly, because this already returns that model. Cool. And we also have here an API layer. So if we go to this API layer, to this program.cs, we should actually be able to add the different things that we need here. So builder services, I have already created here the variable for the connection string. And here let's Alt enter. Why doesn't it work? Reference project val. Okay. iPayment, and this should be the request repository, not iPayment request. Okay. And yeah, Alt enter to also add. And this is, of course, once again, because we also need reference to this layer. And last but not least, of course, we need to go to our controller and actually wire everything up together. So if we take a look at the controller that we have here, we have this payment request controller that right now just returns an okay. It's actually not that it will return much more, but the only thing that we need to do is, of course, right now use the service. So it would be private read-only iPayment request service. That one we actually also need to have here, payment request service. Okay, and of course we need to assign this. Request service equals, okay. What is the problem here? Okay, I don't have a semicolon. iPayment request service request, something like that, and now it should actually work. Cool. And now we can simply just go here in this method and well, just use the service to actually return payment, and everything should be okay. But how is the request service that we named this? Cool. So we should be good to go with this request service right now, and everything should be fine. Okay, let's do a first run through here, and yeah, let's actually debug this, and let's just see if it works, and if it works, then yeah, we should be actually good to go. Okay, the API is building right now, and we will be able to see it in action in just a minute. Cool. So it started, it will open a browser on the other monitor, and I will bring it on this monitor to be able to actually use that and see that everything works. Hopefully everything is okay. I also have added previously the connection string in the app settings JSON file, so that should also be good to go. So it loads here the Swagger UI. It's still loading. Here we have a payment. Let's try it out. And I know for sure that we have it with ID 1. So if we click execute here, I would expect not more and not less that I would have to see the payment request here in the response. And of course, due to simplicity, or well, having simplicity in mind and maintaining or attaining to the scope of this video, I haven't used any DTO. So what we return here is actually our domain model. But of course, if you work in real application, you would have to work with DTOs, with API contracts and things similar to that. But that's actually, or that really doesn't change depending on if you use a DB first or not. And we can see clearly that our application is kind of like working. Cool. So that's actually very, very nice right now. So let's move to the next step and say how we can actually implement this in our application layer, where we actually want to use CQRS. And by the way, in the API, I guess we have to go to the okay, because we have here, it is already installed. Okay, I guess it should be already installed here. Okay, so then we can go here in program.cs, and we would actually have to add mediator. But first of all, let's add the application layer. So we go here for this application application with CQRS, and we'll keep it very, very simple. We will create here a class, and this class will name retrieve payment query, because that is actually a query. And we'll see here that of course it's still running. Let's make it, let's close it. And this is an I request, and that payment and that request will return a payment request. Okay, and here we'll have to add import missing references for this one, and import the missing reference for this one, not from DAL but from the domain. That's important because our application layer should really take the models from the domain layer. So this would be the request, and here in this request we will have only public int request ID. So that's actually the only thing that we will have. Now we will have to create a handler for that. So let's use class interface and get or retrieve. So retrieve payment request handler, and that is, or implements an I request handler of retrieve payment query, and it will return a payment request. Okay, let's add the missing references, and let's also implement sorry, not this one, but we just want to here implement missing members, and this is the task that we want here. It's totally async. Now the difference here is, and this is the most important point, and why I actually wanted to also include this in the video, even if it becomes very, very long, is that when you use CQRS and go for this model with request and request handlers, or commons and common handlers, you actually shouldn't use a service, because this kind of like defeats the purpose of having CQRS if you are still relying on the service, because services tend to actually become a big ball of mud and the source of a lot of bugs in most of the application. And actually this pattern with handlers, with very atomic handlers for each action, is actually a procedure or a way to solve the problems that we had with the more traditional services type of working. So it really doesn't make sense to still use services when you use the handlers. So the only difference here is that in this case, we will have here in this handler private read only, and we will have I request repository. This is what we will actually inject here. So we'll have the I request repository from here, and we'll assign everything here. Okay, and then actually what we do in the task is actually the same that we actually did previously. Return await payment or request repo dot retrieve payment, and here we have this request dot request ID. That's actually what we need to pass in. And right now we just have to actually wire up everything in our API. And of course here we need to do some changes, because actually we don't want the service anymore. That's not something that we will need. We still need the repository, but the only thing that we need to actually do here is, and let's go here above, and builder services add mediator. Okay, and here let's specify a type, and we have the type in that layer, and this retrieve, how did you call it, payment query. And if I have spelled it correctly, reference project, and that's kind of like okay. So if we go over to the controller right now, the only thing that we need to change here is, of course, we don't want the payment request service anymore, but instead what we want is an I mediator. Okay, and that's what we will have here, I mediator, and let's also call this mediator, and let's also change this mediator, and let's change this mediator. And then the only thing that we will need to have here is await mediator dot send, and here we send new retrieve payment query. And here in this retrieve payment query, of course, we need to import the missing references. And here we will have the request ID equals to the ID that we get from the controller. Cool. So right now we should be once again good to go. Let me just debug again and show that it kind of like brings the same result. But in this case, we use this CQRS approach, and we still stick to these clean architecture principles, because we inject the repository directly into the handler. So we don't really need to use services anymore if we are going for this pattern. And the application starts right now. I assume that it should start a little bit faster than previously. And in fact, it is here on the screen. And if we take a look here, we have this payment request. Try it out. ID 1, and let's execute that. It takes just a while until it connects to the database, which is a local database, of course, and then we see that we actually have the same result, but we have actually implemented a slightly different architecture, but still sticking to the clean architectural principles. Now, I know that this video became a little bit longer, but really before we wrap up, I want to come back to also one very, very important thing. Now, if we go back to the data access layer and we look at this DB context class and at our payment request, which is the data model. Now, even in the official Microsoft documentation says that after you have scaffolded the data models, you can actually tweak them to suit your needs, like changing properties or things similar to that. However, this is actually a nightmare when it comes to a real production application with a huge existing database. Don't ever do that. Never touch manually, from my point of view, the data model or the models that are created or scaffolded by the DB context, and of course, never touch the DB context itself. Always when you are in doubt, just perform a new scaffold operation and it should update the existing entity. So don't try to tweak, because the problem is if you start to manually tweak your DB context and your entities, when the database will change, and eventually it will change, then actually you will have an out of sync version of your data entities when it comes compared to the database, and that's really a source for a lot of bugs. So from my point of view, to actually be on a very, very solid foundation, you have to actually do these steps. Use the data models only for data access. Create your own domain model. Use a repository to map the data model to the desired domain model. You can do this manually, as we have seen here in this application, or you can do this via AutoMapper or maybe other libraries, but the idea is actually the same. What you need to do is actually use this repository to translate from the data model to actually the domain model that you want. And you will say, yeah, but if the database changes and you scaffold it and it gets updated, well, you still have to go here and update and wherever you have used it. And that's actually true. But at least in this case, it's not a desynchronization between your application and your database. And if you follow clear procedures, like for instance, if you use AutoMapper profiles, then that's very, very clear. And it's kind of like a way of working. It should be also defined in your documentations and whatever, that whenever you scaffold or whenever you have a scaffold operations, you check then exactly what entities from the data model were actually changed. And then you have to go into the mapping profiles and change those mappings accordingly. So this is, well, a downside of using actually database first is really not the first choice for none of the developers, but in a lot of cases you will be imposed to do it, and in that case you have to find the best way to actually do it in a way that kind of like is also maintainable and less error prone, or as less error prone as possible. That's kind of like important. Cool. I think with this, we have a wrap for this video. I hope you enjoyed it. And if you found this content useful, don't be shy and share it with others, with your friends, with your peers on the social networks, on forums, or wherever you might see it fit. And people that might find this content useful will thank you for that. Also, don't forget to hit the subscribe button and the thumbs up button if you didn't do this already. That would be highly appreciated. Let also others know about this channel. They might want to subscribe too. And last but not least, please comment on this video, ask questions, get the discussion going. I tend to really answer a lot of the questions, or most of the questions. So I am really glad to have a discussion going here. This being said, thank you very much for watching. And until the next time, I wish you the very best.